Hey, this is Mr. James. In this video, we'll be going over the basic vocabulary of different kinds of triangles and quadrilaterals. We will not be going over any sort of properties or theorems in this video, and we won't be doing any sort of numeric or algebraic problems. This video is just about reviewing basic vocabulary of triangles and quadrilaterals. Now, we'll start with triangles. Before we get into the meat of the different kinds of triangles, we're going to need to remember some additional vocabulary. Given this triangle ABC right here, let's answer these 4 questions, and I bet you can try these without me showing you first. Pause the video now and try and answer questions A, B, C, and D number 1. Go ahead and pause the video. The answers will be up in 3, 2, 1. Alright, let's take a look at 1A. To name this triangle, we first use the triangle symbol and then the 3 vertices. In this case, we've got A, B, and C. Now you could choose a different order. For example, triangle BAC, that would be okay, as long as you have the 3 vertices. For B, it asks us to name the side opposite from angle A. Well, here's angle A right here. Now when we talk about opposite, we're talking about this side right here, side BC. And to name that side, remember we always use 2 letters, and since it is a segment, we put a line over the top with no arrows. Of course, you call this CB, as long as you have the line with no arrows over the top. For 1C, name the angle opposite from AB. So if we look at side AB right here, the side opposite that, or I'm sorry, the angle opposite that is angle C. So that'll be angle C. Of course, you could use 3 letters to name this, such as BCA, or angle ACB. Any of those will work. For D, it asks us to name the vertices. Now remember, the vertices are just kind of like the corners. So A is a vertex, B is a vertex, and C is a vertex. Next, we can go ahead and answer number 2 by filling out this grid, including the name of each kind of triangle, basic sketch including any markings, and a written definition and a real-world example of where that triangle might occur. So, there are 2 ways to classify triangles. One by angle measure, how large or how small those angles are, and the other by side lengths, whether it has any congruent or equal side lengths. We'll start with the angle measure. You might remember there are 3 different kinds of triangles classified by angle measure. They're acute triangles, right triangles, and obtuse triangles. Here's some examples. A pool ball rack, as we have right here, is an example of an acute triangle because all 3 angles are less than 90 degrees. They're all acute. This sandwich triangle has 1 right angle in it, 1 90-degree angle. The other 2 are acute, but this makes this a right triangle. Lastly, a coat hanger is an example of an obtuse triangle. It has 1 obtuse angle. The other 2 are acute, but that 1 obtuse angle is what makes it an obtuse triangle. So, let's go ahead and write in some definitions. If I'm going too fast, make sure you can pause the video. A acute triangle is a triangle with all or 3 acute interior angles. An example would be the pool ball rack we just saw. And so if I've got an acute triangle, it could look something like this. Right? All of those triangles are less than 90 degrees. Next, a right triangle is a triangle with 1 right interior angle. So, for example, this is a right triangle, as long as it has 1 right angle. Now, could I have more than 1 right angle? I'll let you think about that question, and we'll talk about it next time I see you in class. Lastly, an obtuse triangle is a triangle with 1 obtuse interior angle. And so let me try drawing an obtuse angle right here. Alright, there we go. And I'll connect the sides, and there's my obtuse triangle. It's not very straight there. Hopefully do a better job than I did. But make sure you've got that obtuse angle right there. Here's a better example. And again, the coat hanger is a real-world example there. We can also classify triangles by their side length. Now, this is taking into account, are any of the sides of the triangle congruent or the same length? We have scalene triangles, isosceles triangles, and equilateral triangles, all classified by side length. Remember, the last set of triangles were all about the angles, where they obtuse, acute, what? In this case, they're all about the side lengths. A scalene triangle has none of the same side lengths. For example, all three of these different lengths in this frame of a bicycle are different lengths. For an isosceles triangle, two of the lengths of the triangle are the same, such as in this penny, this length and this length are congruent, but this length is not. In an equilateral triangle, such as in this yield sign, all three of the side lengths are congruent. It's equilateral. All the sides are equal. That's what equilateral means. Let's go ahead and fill out these definitions. They're pretty intuitive. A scaling triangle is a triangle with no congruent sides. For example, the bike frame. So if I draw a triangle like this, okay, making sure that none of the sides appear to be the same length, I'll mark them to make sure that they are not the same length. 1, 2, and 3 tick marks. That is a scalene triangle. An isosceles triangle, on the other hand, is a triangle with two congruent sides, such as the sports pennant we saw on the other page. So, kind of like this, where two of the sides, for example these two, are congruent, and the last one is not. Lastly, we have an equilateral triangle, which is a triangle with all three congruent sides, such as the yield sign we saw on the last page. And try and, alright, rough sketch, but all of these should have been the same length. Here's a better example right here. Again, if you had any trouble seeing any of these, make sure you go back, rewind, and pause the video. Next, let's talk about quadrilaterals. Now, quadrilaterals are any sort of four-sided closed figure or polygon, such as a lot of these figures right here. Now, we'll come back to these in a second for some examples, but just like before, we're going to need some additional vocabulary before we start. I bet you can answer A, B, C, D, and E for question 7 right here. Go ahead and pause the video and try to answer A through E on question 7. Pause the video now. The answers will be up in 3, 2. Make sure you actually tried this. Let's talk about the answers. Starting with 7A, name the side opposite from side MO. Let's see, here is side MO. The side opposite that across this quadrilateral is side GE, or EG, depending on which way you like to do that. B, name the sides consecutive to MO. Now, consecutive is a new word here. Consecutive means one right after the other, right, or in order. So if you think about, here's MO, again in red now. Consecutive means the sides that are right next to it, almost adjacent. So this side right here, GM, and this side right here, EO. So GM and EO, we would call those consecutive to side MO. Name the angle opposite from angle M. Let's see here. Here's angle M. I'll put this in green this time. Opposite. So across this quadrilateral, looks like angle E. It's pretty straightforward. Angle E is opposite angle M. But now you have this word consecutive again. Consecutive to angle M. So here's angle M in purple. What's the angles that are consecutive to that? Well, those are those angles that are kind of next going around the quadrilateral. So G to one side and O to the other side. So angle G and angle O are consecutive, kind of next to one right after the other, angle M. Draw the diagonals and name them. All right, this is another new word here. Diagonals are any segment that connect the vertices of a quadrilateral on the interior. Now, that's a lot of vocabulary, so let's actually look what that means. This is called a diagonal. This is called a diagonal. Please make sure you're drawing those on your paper. Again, they're any segment that connects the vertices, such as G and O, on the interior, the inside of this quadrilateral. So, for example, GO is a diagonal, and ME right here is our second diagonal. Now, there are a few different quadrilaterals that we'll work with in this class. They are the kite, the trapezoid, the isosceles trapezoid, the parallelogram, rectangles, rhombuses, and squares. Now, you've probably seen a lot of these quadrilaterals before. Here we have a kite. Kites have no parallel sides, but they do have two pairs of congruent sides. See, the top two and the bottom two sides are congruent here. We could also call those consecutive sides since they're next to each other. A trapezoid has one pair of parallel sides. As you can see here on the side of the Connecticut Science Center, the top and the bottom appear to be parallel. A isosceles trapezoid is a type of trapezoid where it also has one pair of parallel sides, but in addition, those non-parallel sides are congruent. It's isosceles trapezoid. You've probably also heard of or seen a parallelogram. A parallelogram is different from a trapezoid because instead of having one pair of parallel sides, it has two. Notice how there are two pairs of parallel sides. A rectangle, as we have here in blue, is a type of parallelogram, again because it has two pairs of parallel sides, but it also has four right angles. Rectangles have four right angles. Lastly, rhombuses are also kind of parallelogram because they have two pairs of parallel sides. But what makes them a little bit more unique is that all of the sides are congruent. All four sides are the same length on a rhombus. Let's take some more formal notes with that. Let's start with kite. A kite is a quadrilateral with no parallel sides and two pairs of consecutive congruent sides. So if I were to sketch that out, here's what it might look like. These two sides are consecutive, meaning one right after the other, and they're congruent. And these two sides are consecutive, meaning one right after the other, and they're also congruent. That's what it means to have two pairs of consecutive congruent sides. Again, notice that there are also no parallel sides in this kite. Next we have a trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides. So for example, there's one side, there's another side. I will mark them as parallel by drawing the arrow on both of them and then join those sides together. Notice that the other two sides are not parallel. A trapezoid only has one pair of parallel sides. An extra vocabulary term I'll throw out here. The two sides that are parallel are called the bases. So those are the bases of our trapezoid. Right there and right there. Those are our bases. Whereas the other two sides, the non-parallel sides here that I'm marking in green, are called the legs. The legs of our trapezoid. So trapezoids have legs and they have bases. An isosceles trapezoid is a type of trapezoid. It's a quadrilateral with one pair of parallel sides, making it a trapezoid, and one pair of opposite congruent sides. So I start the same way I did for a trapezoid, okay, with two pairs of parallel sides, or sorry, one pair of parallel sides, one pair. But then the other non-parallel sides have to be congruent, so I'll put one tick mark on both of them to show they are congruent. Again, an isosceles trapezoid has bases and sides that are legs, just like the other one. So it also has bases and legs. Unlike a trapezoid, a parallelogram is a quadrilateral with two pairs of parallel sides. So for example, here's one pair of parallel sides, okay, and here's a second pair. I'll mark the first pair with one arrow and the second pair with two arrows to signify that they are parallel. A rectangle is a quadrilateral with two pairs of parallel sides, meaning it's a kind of parallelogram, but also contains four right angles. So I'll draw myself a rectangle here. Again, it's got two pairs of parallel sides, just like a parallelogram, but this time I'm going to add on four right angles. Okay, and you can mark those just like I did there. A rhombus is kind of similar. It's a quadrilateral with two pairs of parallel sides, meaning it's also a kind of parallelogram, just like a rectangle, but different from a rectangle, it has four congruent sides. So I start similar to a parallelogram, okay, similar to a parallelogram, like that. It's got two pairs of parallel sides, but now it's got four congruent sides, so all four of those sides are congruent. Remember, rectangles have 90-degree angles, but rhombuses have four congruent sides. Lastly, we have squares. Squares have it all. Squares are quadrilaterals with two pairs of parallel sides, meaning they're parallelograms, four right angles, meaning that they are also rectangles, and four congruent sides, meaning they're also rhombuses. So when I draw myself a square, I'm going to have to load it up with a whole bunch of stuff. Okay, I got the parallel sides of the parallelogram. I got the four right angles of the rectangle, and I've got the congruent sides of a rhombus. If any of this was too fast for you or you missed anything, make sure you pause and rewind to catch all of it. I'll see you next class.